Edwin has a PhD from Indiana University in environmental sciences, and a master's in chemistry from Michigan, and has worked for several decades in mitigation and adaptation on climate change policy in Mesoamerica, particularly in Guatemala. He's one of the lead scientists in Guatemala focusing on this issue, and has served. He's now at the head of the chair of the scientific committee on technology, science and technology for, gosh, I should get it down right here. It's the International Network of Science and Technology in Guatemala. And he's the head of the advisory committee for the Inter-American Institute on Global Change Research. So he's playing a lot of leadership roles in terms of climate change policy, research, kind of transdisciplinary science, in the Mesoamerican region, and also internationally. It's been involved. He was the lead author of the Central America and South America chapter for the IPCC, and the latest the AR5. So he's got a huge amount of experience, and we're really fortunate to have him share his perspective here with us. So I will stop talking and let Edwin get started.
Thank you. Thank you, Hallie, for the introduction. Thank you to all of you for taking the time on Friday afternoon. I know that the weekend is almost here, so I'll try to be brief so you have more time to enjoy your weekend. But I think it's very appropriate that we get together today to talk about Guatemala and Central America, because like I wrote here, today we are celebrating Independence Day, not only for Guatemala, but also for Central America. As you probably know from your history, Central America at the colonial times used to be a single country, a single unit, part of the colony from Spain. So it was on the 15th of September, 1821, when Central America became independent from Spain. Interesting that at that time, Chiapas, which is the southernmost state in Mexico, was part of Central America, and so Chiapas was also together with this whole area. Panama was not part of that unit. Panama was part of Colombia, so Panama had a different story. But nowadays, when we talk about Central America, we always consider Panama as part of the area. So when we talk about Mesoamerica, we are really referring to the part of southern Mexico together with the 7 countries in Central America. So even though it's a relatively small piece of land, we see a lot of diversity because we find a total of 7 countries in there. So the difficult part is to remember all the countries. Guatemala, the first one. Next to Guatemala, we have Belize, which is the only English-speaking country in the area. Used to be a British colony. Then we have Honduras, El Salvador, Nicaragua, Costa Rica, and Panama. Okay, so 7 countries, and then Chiapas, also in southern Mexico, as part of our research area that I'll explain in a minute. So a total of 7 different countries. Hope you memorize them, because there'll be a test at the end. But that's the area that we are going to cover in the presentation. And my idea here is just to give you some general information of what is happening with climatic conditions in the area, and how people have been affected by the changes that we have observed, especially in the last 2 decades in terms of climate variability. But before we focus on Central America, I want to take just a couple of slides to summarize what we know in terms of climate change around the world. I know that that's a difficult topic to talk about here in the US now, so I'm not here to convince anybody. I'm just here to show you what the data shows, right? And this data comes from the latest report from the IPCC that Hallie mentioned, the 5th report that was published in 2014. I was part of the chapter dealing with Central and South America, but these graphs come from the summary for policymakers, which summarizes what's happening around the globe. And this report was interesting because it was the first time that IPCC indicated that the warming of the planet was unequivocal. In other words, there is basically no doubt. No, the certainty of the data is higher than 99%. We know in science that we'll never be able to achieve 100% because in science there is no such a thing as 100% certainty. But 99% or more is already highly certain, and so IPCC concluded that all the data showing the temperature changes in the last century around the globe basically indicate that the planet is warming. Okay? We have had at least 1 degree of temperature increase in most of the areas of the planet. In some areas have experienced increases of 2 or even 3 degrees in the last century. So that's what we call global warming. And together with the global warming, we also see a high variability in the rainfall. Different from the previous map, in this map we see that we have 2 different shades of color. On one hand, and this map is representing how the rainfall has changed in the last, in this case, it's about 60 years. And so with the rainfall, we see that some areas have bluish colors, meaning that some areas are actually getting more rainfall in the last 60 years, including the eastern part of the United States. But some other areas have yellowish colors, meaning that some other areas are getting drier. For example, the western part of the US. And so in general, what we have seen in the last 60 years is that the 2 extremes are getting more extreme. So the dry areas are getting drier and the wet areas are getting wetter. And this is partly a result of the warming of the temperature. So basically what we're seeing here is that the variability in rainfall is becoming more extreme. And that is what we usually refer to as climate change. So we do have 2 different phenomena. One of them, the warming of the planet, global warming, and we also have the increase in the variability of the rainfall, mainly referring to a change in the climate or climate change. So we know that that is happening. Up until 10 years ago, the data was not that conclusive. Now the data is conclusive that the planet is warming. So the next question then that could be presented is, why is it warming? Is it happening because of a natural process? Or can we see that we as humans have something to do with it? And so these graphs also come from the IPCC report. And basically these graphs are showing 3 different sets of data. The black line shows the observed data in terms of temperature, in this case, right? Temperature on land and oceans, and the heat content of oceans. So the black line is the observed data. And then on top of that, we have the data derived from 2 different types of models. If we use models that only include natural forcings, otherwise, if we only include variables like, for example, the amount of heat that comes from the sun or other variables that influence the climate, then we get the bluish line in the model. This is not really a line anymore because the models, of course, have some variability, and so we have more than a line. We have like this wider color indicating what happens if we only take into account natural variables. We see that especially in the last 50 years, the model is not able to reproduce the rapid increase in temperature. The only way that the model can reproduce the rapid increase in temperature is if we include anthropogenic variables in the model. In other words, if we only consider natural variables, it is impossible to explain why the temperature has increased so quickly in the last 50 years. Only if we include human variables, then we can explain this increase. In other words, then the planet in the past has always warmed, has always cooled down, but usually the natural warming or cooling down of the planet occurs in longer periods of time, usually thousands of years. Whereas now, within 100 years, we have seen a change of 1 degree. It is impossible, pretty much, this data shows, to explain a warming of 1 degree in 100 years if we don't take into account human variables. And that's what IPCC used to determine that it is extremely likely. So now the probability is a bit lower, but still 95%. Extremely likely that we as humans have been the dominant cause of the warming that has been observed, especially in the last 50 years. So basically we know that the planet is warming, and we know that it's warming up too fast to be a natural process, and therefore we know that there has to be something that we as humans are doing to make the planet warmer. What are we doing? Well, we are putting gases out there that are able to trap heat, and those gases are known as greenhouse gases. Unfortunately, those gases are transparent, they are invisible, and so the atmosphere looks pretty clean. It's not like if we are putting out smoke that is kind of dark. So even though the atmosphere looks pretty clean, it is getting polluted with these gases that have the ability to trap heat. And so we have more of these gases trapping heat, and because we have more heat being trapped, then the temperature is going up. Now the question then is, who is doing that? Which parts of the world are actually producing these gases? This graph over here is trying to represent the amount of pollution that is being produced in terms of these greenhouse gases as we see different areas of the world. The writing is a little bit small, so I'm going to explain it to you very quickly, but basically this larger part of the entire rectangle represents all the pollution being produced. And each one of the rectangles here represent different regions of the world. For example, this dark blue rectangle represents the pollution coming from Asia. So this is a very large rectangle because here we have India and here we have China as well. So a lot of pollution coming from there. The rectangle next to them represents Canada and the United States. So only two countries in North America are responsible for 15% of the pollution in the world. Next to Canada and the United States, we have Latin America. So all the countries in Latin America, starting with Mexico, the 7 countries that I show you in Central America, and I don't know how many, I think it's 15 countries in South America. All of those countries together only add to 9% of the pollution, compared to 15% produced by only 2 countries. And so we see that the amount of pollution being produced is very different depending on the countries. No? And Latin America has 9%, and that's because we include here large countries like Mexico and Brazil. If we were to remove countries like Mexico or Brazil, the square would become very small, probably 1%. And if we were to see a square only for Central America, we wouldn't be able to see the square. The square for Central America would be about 0.8%, 0.5%. And so, in other words, the pollution that Central America is producing is extremely small, pretty much undetectable compared to the rest of the pollution of the world. And yet, as we're going to see later in the presentation, Central America is receiving a lot of the impact of this pollution. So we have a situation here in which we are not responsible for polluting the atmosphere. Others are responsible for polluting the atmosphere, but we are getting a good portion of the impacts of that pollution. And that's why when we talk about climate change, we often hear expressions like injustice, no? Doesn't seem to be a just or a fair situation because we didn't cause the problem, but now we are receiving the impact of the problem. What kind of impacts are we seeing? Well, this graph also comes from the IPCC report. This is now more focused on Central and South America. But basically, these pictures here show the kind of things that we are seeing in Central and South America. For example, we see a thermometer in red with an upward arrow, meaning that in all areas in this part of the world, we see that the temperature is increasing. In terms of the rainfall, that would be the next icon. In some areas, we see that the temperature is the rainfall is decreasing, but in some other areas, we see that it's variable. It's changing a lot. In some areas like Argentina, for example, the amount of rainfall is increasing, similar to the US. And so in terms of the rainfall, climate change has been beneficial for this area because this area is relatively dry. These are the pampas in Argentina, no? A natural grassland. So now the pampas are getting more rain, and therefore this area is more suitable now for agriculture. And so at least for this specific region, climate change has brought some changes that are beneficial to produce more food in the area. Beyond that, we see that in general, together with increased temperature and variable rainfall, we also see, for example, in some areas, we have here a mosquito and a red arrow going up, meaning we have more mosquitoes everywhere, and mosquitoes bring more illnesses like dengue, like chikungunya, like Zika, and so many other illnesses now. And so basically, we see mosquitoes now going to other places where before they were not, and now we see these illnesses also going to those areas. A very good example is, for example, Guatemala City. Where I live, Guatemala City is a city on the mountains, 1,500 meters above sea level, 5,000 feet. So about 20 years ago, we didn't have a problem with mosquitoes, at least mosquitoes infecting us with dengue, a very common illness now. Dengue was something that was very common only in the lowlands, in the close to the ocean. But now, more and more, it has become very common to get infected with illnesses like dengue or malaria, even living on Guatemala City at very high altitudes. Basically because the temperature has become warmer, therefore the mosquitoes can climb higher up on the mountains. So we are seeing already some changes in the area, and together with those changes, what we saw, especially in the last decade, was a huge increase in terms of extreme events. This graph over here is showing the number of extreme events, for example, wildfires, droughts, storms, and floods that we have observed in Latin America in every decade. So we see that in every decade we see a little bit more of extreme events, but the decade of 2000-2009, the number of flooding and storm events just went really high. So this was a decade where we observed a lot of hurricanes, a lot of tropical storms, and so basically we had one hurricane going through the area. We were just recovering from that hurricane, and 3 years later another hurricane coming to the area, recovering from that hurricane and another storm. And so it was a decade where we saw over and over flooding and landslide occurring because of extreme events. And those extreme events ended up being very costly for the area. It's being estimated that each one of those major hurricanes that hit the area cost to our countries as much as the economic growth for that year. In other words, let's say that the economy grew that year 5%. Well, that 5% was the cost of the hurricane hitting the area. So basically, for every hurricane that hit the area in that decade, that year, the countries in the region basically had no economic growth because all that growth was lost in all the damage caused by the hurricanes. Now, we are used to talking about hurricanes and tropical storms. Those are extreme weather events, of course, that cause a lot of damage in terms of landslides and flooding. But the thing in Central America is that the area is so fragile that we don't really need to have a big storm. We don't need to have a big hurricane in order to get problems like this. For example, the rainy season in year 2007 was a year where we didn't get a single hurricane or tropical storm. Yet in Guatemala, we had a total of 71 people killed because of extreme rainfall, 28,000 people affected. So even a heavy rainfall in one afternoon is enough to create situations like this. Same thing happened in 2008. We didn't have a single tropical storm or hurricane going through the area, and yet we saw a lot of people affected. And of course, when we did see a storm or a hurricane going through the area, the number of people affected was just much higher, no? And together with this extreme rainfall, we have seen also interesting things like the picture down here. It's probably difficult to see, but what we see here is some snow on the ground. Usually, we don't get snow in Central America. The area is too warm for snow. Even in the cold season, it doesn't get cold enough. But now, more and more frequently, we are seeing these snowfalls in the cold seasons. And so the cold season is also bringing us extreme cold weather that we didn't have before. And so what we are observing on the ground is that more and more we are seeing things that are happening that didn't happen before. And so more and more people are being aware that there is something happening with the weather. no? Now, together with the extreme events that I was talking about, we have to realize that the area itself is very prone to being affected by disasters, in part because of the poor economic situation of the population. This graph over here, written in Spanish, is showing the risk of being affected by a natural disaster. So every little dot represents how many people could be affected by a disaster, and basically the different colors show whether you live in a developing country or whether you live in a wealthy country, in a developed country. And so basically in the decade or in the years of 1980 to 1984, if you lived in a developed country like the US, your risk was represented by one dot. And the risk if you live in a poor country was much higher. Okay, so to begin with, in the 80s, we were already in a very difficult, different situation, no? Poor countries had already a lot of higher risk than wealthy countries. And the problem is that in the year 2000, the risk for poor countries basically doubled, but the risk for wealthy countries pretty much remained the same. And so we see that the risk of being affected by an extreme event is highly dependent on the economic conditions, no? Whether you are in a wealthy country or in a poor country, the probabilities of being affected are very, very different. And we see that now that we have hurricanes going through the area, no? That has happened very recently, so we have now a clear picture of, for example, what happened with Irma, no? Irma going through the islands of the Caribbean, the number of people affected much higher, the number of people killed much higher. When it came to Florida, thank God, because of the way people prepared, because of the evacuation they had, the number of people affected way lower. No? And so that's, Irma is really a good example to show this situation over here. No? How the economic situation of the country really makes a big difference in the face of one of these extreme events. Now, that's talking about what has happened in the past. All that I showed you is not really models into the future. All what I show you is what already happened, what we have already seen on the ground. But now the question is what's going to happen in the future? How can we tell what's going to happen in the future? Well, we have the history of how the climate has changed in the past. So in theory, we can develop a model and try to run that model into the future to try to understand how the climate is going to behave in the future. The problem is that one of the most important variables in those models is the human variable. We saw before that we humans do have a strong influence on the climate. Before we didn't think we could do it, but now we prove that yes, we have a strong influence on the climate. And so if we want to model what's going to happen in the future, we should be able to model what are we going to do as human beings. And unfortunately, it's very difficult, pretty much impossible, to model what we're going to do because human behavior is very unpredictable. And so rather than having one single model into the future, what we develop are scenarios. So basically, we take the history of the climate in the recent years, and we try to put that forward, but with different scenarios, meaning different possibilities of what we as humans are going to decide. For example, one scenario could be, well, we realize that we have been polluting the atmosphere. We realize that that's a bad thing to do. It's not good to be throwing out all these polluting gases into the atmosphere. So we make the decision to stop pollution. So that's the optimist scenario. So if we have that optimist scenario, then the temperature would increase more or less 1 degree above the 1 degree that we have already increased in the last 100 years. So in the optimistic scenario, we get more or less an increase of about 2 degrees if we compare to the base year of 1850. But beyond the optimistic scenario, we have other possibilities. The other possibility would be the opposite completely, no? Saying, well, no, we don't believe that we can fix this problem. We don't believe that we should do something about it. Now we hear a lot about that situation now. We decide not to do anything. So the scenario where we don't do anything is the red line over here. That scenario comes to an increase of temperature of about 4 degrees, and those 4 degrees will be on top of the degree that we already have, so it will be a total of 5 degrees on top of the base temperature of 1850. And so basically, what's going to happen in the future really depends on our decisions, whether we decide to stop polluting the atmosphere or not. And of course, one could say, well, this is going to happen so far into the future that we shouldn't really worry about it, no? This is going to happen in 2100, so none of us are going to be living in that time, so why should we worry about, no? Well, many things why we should worry about. We all, many of us have children, no? So we should worry about our children. Our children might be living in this in that time. Some of us have grandchildren, they will be living in that time. And so if we worry about the next generations, we should worry whether they're going to have to cope with a planet that is 2 degrees warmer, or whether they're going to have to cope with a planet that is 5 degrees warmer. Right now, all the problems that I showed you in the previous slides have happened with only 1 degree of temperature increase. That's what we have seen in the last 100 years. So with 1 degree, we already see a lot of extreme events. Imagine now what could happen if the warming would go 3, 4, or 5 degrees. So there's definitely a reason for concern. Now, again, the reasons for concern are different, whether you live in Guatemala or whether you live in the US, because we see that the risk of being affected is way higher in Guatemala than in the US, right? And so, as a result, it is harder for people here in the US to realize that, yes, we have to do something about it, because it doesn't seem as pressing. But for us in Guatemala, it is definitely more pressing for all the information that I show you and some other information that I'll share with you. So the pressure on acting is different depending on where you live, because we are getting the impact of this problem at a different level. The problem is that even if we in Guatemala decide to do something about it, it doesn't matter, because we are not really the big polluters. The pollution, as I showed you before, comes mainly from the US, from China, and from other European countries. And so even if we in Guatemala decide to do something about it, we really rely on the US and Europe and China doing something about it. Otherwise, it wouldn't make a difference for us. These are some models that show what's going to happen in the future. Again, here, I had different scenarios, an optimistic scenario, a pessimistic scenario. So basically, that results in this kind of graphs. So these graphs are for temperature. These are for precipitation. These are the optimistic scenario, what's going to happen if we do stop polluting. This is the pessimistic scenario. This is, this is the optimistic scenario and the pessimistic scenario. So scenarios go horizontal. And this is the middle of the century and the end of the century. So basically, if we do stop polluting, if we have the optimistic scenario, we see that the map still looks yellowish. So the area still warms up, no? But it only warms up to 1 degree. If we don't do something about the pollution, then the warming continues, but it's much higher. It's up to 4 or 5 degrees. So what's going to happen with the temperature? It's going to get hotter, regardless of what we do. But it's going to get less hot if we do something about it. It's going to get way hotter if we don't do something about it. With the precipitation, the story is different, because we have some areas that get dry and some areas that get more rainfall. And again, here we have the optimistic scenario, the pessimistic scenario. The two of them are similar, but the pessimistic becomes more intense. And basically, we see that some areas are bluish, meaning that they get more rainfall, but some areas are brownish, meaning that they get less rainfall. If we try to zoom in Mesoamerica, this is a model developed in a university in Mexico. This is the current situation. This is what the rainfall looks like in the area now. And this is what the rainfall looks like in 1990, at the end of this century. So basically, the blue colors mean areas that have a lot of rainfall. So we see, for example, that southern Mexico gets a lot of rainfall here. Guatemala gets a lot of rainfall, especially around the Caribbean. But we see that the models show that in the future, in 2090, the blue areas pretty much disappear. So in general, the models are showing that as we move along this century, we're going to get less and less rainfall in the area. So basically, we need to prepare ourselves to live in an area that will have less rainfall available. Okay, and like I showed before, the rainfall patterns are very different throughout the world. And so in the US it's the same. Some areas are going to get more rainfall, especially the east. Some areas are getting less rainfall, especially in the west. This is a little bit hard to see because it's not high quality graph, but this is just to show you a model that was done by a climatologist in Italy, Giorgi. And Giorgi did an estimation of the different areas of the world that were more responsive to this changing climate. So these red dots indicate a regional climate change index. The bigger the dot, meaning that the index is bigger, meaning that that area is going to be more responsive to this extreme change in the climate. And we see that at least in the tropical areas, the biggest dot is right here in Mesoamerica. And so out of this research is that now we understand that Mesoamerica is one of the most responsive regions to climate change in the tropics. And together with Mesoamerica, we also see big dots in the northern parts of North America, and also in some parts in the northern Europe and Asia. So basically we see that if we get closer to the North Pole, those areas are experiencing more changes, but also in the tropical areas, Central America and Mexico are also getting a lot of these extreme changes. Now, what challenges and opportunities are presented by this situation? Most of them are challenges, but as we're going to see at the end, there's also some opportunities. And what we have to understand, and going back to the idea of having different impacts and different risks depending on whether you live in Guatemala or whether you live in the US. This graph comes from the IPCC report as well, and this graph is showing us that the risk of being impacted by an extreme event is really the combination of three different types of variables. Not only we have to think about the level of the actual hazard. For example, whether we have a hurricane or whether we have a storm. So this is the side of the graph, the level of the actual physical event impacting the area. Of course, the bigger the event, the higher the risk of being impacted. But we don't have to only focus on the event itself. We also have to think about the exposure. And exposure has to do with where people live, or where the event is hitting. So if the hurricane is hitting an area that has no population, if the hurricane, like right now, Jose, I think is the other hurricane now, sitting in the middle of the ocean, there is no people there, so the exposure is basically zero. Therefore, the risk is basically zero. So if we have no people where the event is happening, then the risk drops considerably. On the other hand, if we have more people, that means that the risk is going to be higher. The problem with this equation is that we know that we now have more people. Population is growing all over the world. Population is doubling more or less every 50 years or so. And so basically, we are getting twice as many people every so many years because we have a rapid population growth, and therefore the exposure is increasing, and therefore the risk of being affected by extreme events is also increasing. Together with extreme events and exposure, the last variable to consider is vulnerability, how vulnerable people are. And the vulnerability is related to the socioeconomic condition of people, whether people have the money to protect themselves or not. So if I live in an area that is prone to a landslide, but I have the money to build a concrete wall to prevent that landslide, that makes a big difference. But if I live in that same area and I have no money, then I have more probability of being affected by the landslide. But even if I'm affected by a landslide, if I have economic resources, it's much faster for me to recover from that impact. If I don't have any economic resources and I lose my home, for example, it will take much longer for me to recover. So we see that vulnerability is closely related to the economic resources. And again, that's where we see a big difference between developed countries and developing countries. Okay? So having in mind these three variables, it's important to understand what is happening in the area, because as we see in these graphs are showing, for example, the income that we see in Latin America. The blue line represents the income for South American countries, and the red line represents the income for Central American countries. In here, in the lower graph, we have the poverty level. How many people live below the poverty level line? And see, when we talk about poverty, the two lines invert, no? So Central America now is higher, South America now is lower. So basically, we see that the income in South America is much higher than the income in Central America. So we have less money available. Therefore, like we saw in the previous graph, we would expect a higher vulnerability in Central America. If we see the level of poverty in Central America, it remains extremely high. If we see this graph over here, this is 60%, 40%. So basically, the level of poverty in Central America is around 45%. That's extremely high. That means that almost 1 out of 2 persons in Central America live below the poverty line, meaning that 1 out of 2 people in Central America really don't have the resources to protect themselves against these natural disasters. So that's part of the reason why we are seeing so many people impacted, even by smaller events, not necessarily a hurricane, just a rainfall, like I was saying, is enough to impact people because of this high poverty level that we see in the area. Now, basically what we are seeing is that Central America is an area that already has quite a bit of economical problems, socio-economic problems. So in Central America, we have had to deal with problems of water, food security, poverty, health problems. So those were existing in the area way before we were talking about climate change. But now the problem is that climate change, or this changing climate, if you don't like the word climate change, because now we are not supposed to talk about climate change, the changing climate is now producing that these problems are becoming worse. No? So not necessarily we have to say that our problems are due to climate change, but what we're saying is that the same problems we had before now are becoming even worse because of this changing climate condition. For example, in health, like I was saying to you, no, we already had a problem with dengue, with malaria, but dengue and malaria were only in certain areas of the countries. But now dengue and malaria are everywhere because the mosquitoes are going everywhere. No? Same situation with food security. We always had problems with food security, but now with this change in rainfall, the food security problem has become even worse, like I'm going to show you in a minute. This graph is a quick visual way to compare the infestation by dengue, the morbidity by dengue, how many people get sick of dengue. And what we were trying to do here is to find some correlation with the change in temperature. So this is the average temperature for the last 5 years where we have data. And this is how many people got sick with dengue. The correlation is still weak. If we do this correlation, it still gets to only 30% or so, because meaning that there are other variables influencing why people are getting sick with dengue. But we do start seeing some correlation. So we know that temperature affects where mosquitoes can go, and where mosquitoes can go affect where people will get sick. No? So there is some correlation there. But more than the correlation with illnesses, I was mentioning before that the correlation with food security is even stronger. What happens is that in the region, even though we have plenty of rainfall, it's an area that gets a lot of rainfall, that rainfall is really very distributed into very distinct seasons throughout the year. The blue line over here shows the rainfall in one area in Guatemala, somewhere around here, but it's just an example of what the rainfall pattern looks like. Rainfall in the region, not only Guatemala but Central America, is usually distributed in 6 months. Between May and October, we get all of the rainfall. And so we have 6 months where it rains a lot, and then we have 6 months where it basically doesn't rain at all. So we have had this situation always, and so people are already adapted to trying to survive with 6 months of no rainfall. And basically, most farmers in the area know that they have to plant their crops in April because they know that in May we're gonna get the first rains to irrigate their crops. Because most of their crops don't have any artificial irrigation. They rely on the rainfall for their irrigation. Well, the red line over here represents the rainfall in 2014. So in the last 5 years, we had this problem of basically the rain in May and June disappearing. So instead of getting a lot of rainfall in June like we used to, basically in the last 5 years, we didn't get any rainfall in those months. And you can see what happened, no? The farmers will plant hoping for the May rainfalls. No rainfall would come in 2 or 3 months, and they will lose their crops. And therefore, the food insecurity that they experience would be way higher. And so even if we don't get a full drought, because we still got some rainfall, so this year was really not a full drought year, just the fact that we got a late beginning of the rainy season affected farmers tremendously, especially because they have no way to irrigate their crops. And so basically what we see is that a lot of the people who live in areas where it's fairly dry during the year are really relying a lot on these early rainfalls in May. And those are the areas that are marked in red over here. And if we see Central America, it's pretty much the same. So basically the areas that are marked here in color are the areas that have at least 4 months of dry season. And so these are the areas that are really waiting for the May rains. And if the May rains don't come, then they really have a big problem with their food production. So this is what we are calling now the dry corridor in Central America. So it's really not necessarily a fully dry corridor, not dry like it is here. If you go to those areas, it doesn't look dry at all. But it is dry enough because we have at least 4 or 5 months with no rainfall. And so farmers in this area are really waiting for the rain to get their agricultural productivity going. So it's a big problem now in Guatemala and Central America in terms of food production, the high dependency on these early rainfalls. There are some farmers, especially the large plantations that grow export crops, that do have irrigation. And so, for example, in the Pacific lowlands of Guatemala, we have large plantations for sugarcane, for export. We also have plantations for fruits, for example. The bananas that you eat here usually come from Central America, no? Guatemala, Honduras, sometimes from South America. So these large plantations are highly technified, so they do have some irrigation systems in place. But what has happened in the last years is that because of the decreasing amount of rainfall, when they withdraw water from the rivers to irrigate their fields, they have basically dry out the rivers. No? So this picture is of a river in the Pacific lowlands in Guatemala taken last year. And so it is really quite surprising to see a river like this. It's a big river, it's a lot of water, all of a sudden going completely dry. And in part, not only because of decreased rainfall, but also because people were taking too much water out for irrigation. And you can imagine that the community living downstream from this river would not be happy at all. No? And so there was a lot of conflict between the local communities and the farmers growing their crops for export. No? And so the situation last year prompted a big discussion on trying to come up with a better law that would regulate how much water you can withdraw from a river. And so basically, we were a country that always had plenty of water, but now, at least in the last years, we have suffered this situation in which we now have to rethink the way we are managing our water resources. And very quickly, at the end of the presentation, I just wanted to share some of the experiences we had with the coffee project that Hallie was introducing at the beginning. This is a project that we did in collaboration with several universities, including Arizona, with Hallie. And it's basically a project where we were working with coffee producers in different areas in Mesoamerica. And the idea was basically to try to understand what these coffee producers were experiencing, what they were observing in terms of the changing climate, what kind of stressors they were facing in terms of not only a climate change, but also in terms of fluctuations in the prices. Coffee is a product that has a lot of changes in the international prices. And so the farmers are really exposed to these changes a lot. And so basically, this is a project that ran for about 10 years in which we were trying to understand how these coffee growers cope with all these changing situations. And we have a lot of information, but I just wanted to summarize some of the interesting information. We asked farmers, for example, in 2 occasions, in 2003 and 2007, what are the main stressors, what are the main things that really affect you? And so in both cases, in both years, they said, well, prices, really, how much prices change is what was really affecting us. Climate or weather was over here, especially in 2003, was really not that high. So not that many people were worried about climate situations in 2003. That increased tremendously in 2007, more than double. Part of the situation was all these storms that I told you about. No, remember that graph that I showed you with the storms in the decade of 2000? So when we first asked them in 2003, they were saying, no, the climate is not so bad. But after seeing so many storms over and over, they started to think, well, yeah, we do have some problems with climate. But even if we have problems with climate, prices are still important, no? And so what we see is that people are affected by climate, but of course they are also affected by other problems. And so people are trying to cope not only with a single problem, but they're trying to cope with many problems, no? The changing climate not only affects the rainfall, it also affects the temperature, like I was saying before. And in terms of coffee, that's very important because coffee has to be grown at a very specific altitude. And so if it gets warmer, then the same altitude might not be suitable anymore for coffee. So they might have to go higher. But if they go higher, of course, up in the mountain, there will be less land available for cropping coffee. And so these 2 maps are showing the suitability of growing coffee in Guatemala. We have similar maps for the rest of Central America, but I only show here Guatemala. This is the current situation in Guatemala. So the greenish and yellowish colors show the areas that are adequate for growing coffee. And what we see is that in 2050, or about 30 years from now, a lot of the yellow or green areas have turned into reddish colors, meaning that the area is no longer suitable for growing coffee. So basically, as the climate gets warmer, the same region at the same altitude in a mountain might not be suitable. They might have to move to a higher altitude. But sometimes there is no place to go up, no, because sometimes there is no more land up in the mountains. So we asked the farmers, what are you doing to adapt to this changing climate? Well, many of them said, well, we cannot do anything, no? This situation seems to be coming from God. It's bigger than what we can think of, so there is nothing we can do about. Many people are feeling that way. This is just too overwhelming to do something about it. Some other people are doing some other things. This is a list of what they are doing. Diversification, that's probably the most important thing, no? Do not rely only on one thing. If you're a farmer, try to do something else. If you grow coffee, try to grow different things, because if your coffee harvest fails, then you try to have something else for your income, no? Other things that are important, financial support, very limited to them. Technical support, also very limited. Being part of an organization, to get help from an organization. Those are things that we see are helpful for farmers to cope with this situation. And so out of that research, we came up with a bunch of suggestions on how to improve the capacity for adaptation for farmers. But these are things that are fairly obvious, but now we see that they do work in the field, no? People were responding to that these things really help them. For example, diversification, like I was saying, you know, access to financial instruments, to loans, or to insurance, no, farmer insurance. That would be ideal, but it's difficult to get in the area. Right now, nobody offers insurance for farmers in the area. Increased technical assistance, increased access to information, knowing better what's going to happen with the weather next year or next month, you know. And so there's a bunch of situations that can help people adapt better to a changing climate. But many of these are not really in the hands of farmers. Many of these are really in the hands of central governments or in organizations helping the farmers. And so many of these suggestions were not really directed to the farmers, but to the organizations supporting the farming activity. And so the opportunity that we can see in the problem is to be able to change the development patterns. The area is an area that is highly impoverished, like I showed you before, an area with high poverty, very unequal development patterns. And so if you want to say it that way, climate change is a good excuse to try to change that pattern. No? We have struggled with trying to have a more equal development process in the area. It has been extremely difficult. There's a lot of disparity, but now climate change would be yet another pressure to try to bring all these people in poverty out of that situation, to try to help them cope better with the problem of climate change. And with that, I finish, and I thank you for your attention. Hopefully we have some minutes for discussion. Thank you.
We have a few minutes for some questions, some topics for more elaboration. So if you want to handle the questions.
Could you go to the slide with your the natural disasters that were broken up by cubes? I guess I'll wait for this.
The squares that
Yeah, when it showed the increase in storms.
but that was the emissions, no? The graph that showed the emissions. Who was?
No, this one, that one.
Oh, this one. Okay.
Okay, so what I'm curious about is it shows that wildfires.
Have not increased that much.
Okay, so that's what I just wanted to make sure.
Yeah.
It was higher up on the graph.
Yeah.
I was just wondering.
Yeah.
Okay.
Yeah. Here we have to understand that there are several factors at work. No, we have more flooding and more storms, but we also have more disasters because we have more people. So we have both situations at work. No, so we see here more exposure to extreme events, but we also see more people being affected because we have more people in the area.
You spoke briefly about population increase.
Yeah.
But we've got, what, 7.5 billion people in the world now by 2050, potentially 10 billion?
Yeah.
Can you speak about the acceleration that's going to have on temperature, on drought, on resources? Because I think the expectation is that Africa and South America are the two continents that are going to explode in population. Do you have any thoughts or anything more to say on?
Yeah. Basically, not only climate change, but other environmental problems that we are facing are really derived of two main variables. One being the number of people. And of course, if we have more people demanding resources and producing pollutants, we're going to have more pollutants and less resources. So the number of people is definitely a big variable to take into consideration. And like you were saying correctly, certain parts of the world are the ones that are really exploding. So when we talk about demographic explosion, it's not really something uniform throughout the world. In fact, Europe, for example, is not exploding at all. It's actually contracting. No? So we see the explosion in places like Southern Asia, Latin America, in some areas of Latin America. And so, yeah, the explosion of the population is really focused in areas that are also growing quickly in terms of economic income, because that's the second variable that you have to take into account. You have to take into account not only how many people you have, but also how much the people are consuming. No? And so, for example, Europe is an area where population is not growing very quickly, but their income and their consumption is really growing. And so their per capita consumption there is much higher. No? The same situation happens here in the US. The population growth in the US is much lower than in many parts of Latin America. So we have more people or increasing people in Latin America, but the per capita consumption here in the US is way higher. No? And that makes a big difference. So one person here in the US, in terms of greenhouse gases, for example, can pollute up to 10 times more than a person in Latin America. So even if we have a faster growing population in Latin America, the per capita consumption here is so high that the pollution here is much higher, no? And that creates an interesting problem, because we also have a problem, for example, of immigration, no? We have a lot of people from Central America, from Mexico, coming to the US. And the people who usually come illegally to this country are people who live in poverty in those countries. And so their emissions of greenhouse gases and other pollutants when they live in their country is really low. But when they come to this country, their emissions go way higher, no? And so by every migrant that we send to this country, then the pollution, the total pollution in the world increases a lot. So you have to consider not only how many people, but also where they live.
My name is Shay Alvey. I'm a community director with University Housing. I'm curious if you can go to the diagram that showed the risk, talking about vulnerability and the location, all that kind of
Yeah, the one that has the different variables defining the risk.
Yes.
This one, right?
Awesome. This I found incredibly fascinating. I haven't seen it presented in this way.
Okay.
So I'm curious, in the context of educating people of why this matters to them, how to change their behavior to help lessen our environmental impact. How do you approach the conversation when someone has very little risk in terms of their vulnerability, especially just given in a privileged society that we have here?
Yeah.
Living on a college campus, things are pretty much at your fingertips. You don't have to work to get food. You don't have to pay for air conditioning. All of that kind of stuff.
Yeah.
How do you have a conversation with individuals who fall in that category to take notice of what's happening around the world and start to change their behavior?
Yeah. No, it's a very important but difficult question, no? And unfortunately, the centers of power around the world are located in areas like you were describing, no? Areas with low risk, or areas that are able to cope with that risk in a much better way. And so the decisions around the world are being taken by people who experience lower risk than the average of the majority of the population. And so basically it's a problem of communication, like you're saying, you know, a problem of making people understand, well, what you're doing here is really affecting people in other parts of the world. We are used to thinking of pollution in a more localized way, no? If I pollute my river, it's gonna affect people around the river. If I pollute with solid waste, with trash, then it's gonna affect the people around me with that trash. But the problem with greenhouse gases is that those are gases that distribute around the world in the atmosphere. And so it doesn't really matter where you produce those gases, where you produce that pollution is going to be distributed evenly around the world. And that's the problem, because different people pollute at different levels, like I showed before, and different people experience the results of that pollution in different levels, but the pollution gets distributed around the world. And so that's a difficult concept, like you said, to explain to people, and especially if you live in an area where you are not affected by that situation, no? But you're very right. This diagram, it would be ideal that people understand this diagram. It would be ideal that we talk to people about this diagram, because not only it shows that we have three different variables to consider. It also shows that there are some feedback loops, right? I didn't have time to explain that, but these arrows over here are feedback loops, no? Because what we are saying is that the vulnerability depends on how wealthy people are. So if people are more wealthy, then they have more resources to protect themselves. But if people are more wealthy, the way we have done it now, that means that they are using more energy. And if they use that energy from fossil fuels, from oil, from coal, that means that they, in order to become more wealthy, have produced more pollution. And that pollution has resulted in a stronger change in the climate. And so here is a negative feedback loop. In order to reduce the vulnerability, we have to make people more wealthy. But if we make them more wealthy the way we have done it so far with oil, that means that we're going to pollute more, and then we're going to get the problem worse. And so the only way out of that loop is to be able to become more wealthy, but not relying on oil, but relying on other sources. And so many people always wrongfully claim that all this talk about climate change is really a talk against development. And there is nothing farther from the truth, because I just said in my last slide, no? For poor countries, the solution is to develop, no? In Guatemala, the solution against climate change is to make sure that people become more wealthy, that we develop the country, that we bring people out of poverty. So the solution to climate change is to promote economic growth, but to promote it in a different way, because the economic growth that we have experienced in the last 100 years is what brought us to this situation, relying on oil. So even though it's of course bad for some people if we say we don't want to use oil anymore because they rely on oil, we have to get rid of it. No, we have to stop using oil. Luckily, we have other sources. We have plenty of sources of energy that we can use. And even the same oil companies, they don't have to lose money. They just have to switch their source, no? So if you're a company relying on oil, now you can be relying on solar energy or relying on wind energy.
Just one more.
Yeah. Well, like here in Arizona, we have a lot of crops, but we pump out groundwater, we pump water from, scarce sources. There are rivers, we have very little, but we're using all this water, and that, to me, just seems like we got the wrong place to be growing crops. But economically, it works. How do
Yeah.
you
Yeah.
And what can you do about it?
Yeah,
How do you
no.
justify it? What can you do?
You're very right. So this region is really an example of what money does, no? It makes a difference, no? So here you're doing things that you shouldn't be doing. So this area, you shouldn't have crops, but you are able to grow crops, no? It's actually quite amazing when you fly over the area, no? Because you see desert, and all of a sudden when you approach a city, you start seeing agriculture, and say like, wow, this is amazing, no? They changed a desert into an agricultural land. And they were able to do so because of technology, but technology requires money. And so really, this area is an example of how economic growth can really change the whole picture, no? And like you said, it works, no? It works. So the question is, well, how can we translate this to other areas? I was saying, for example, in Guatemala, we have the problem that people don't have irrigation. They have no money to invest in irrigation. So it's a negative feedback, no? Because they are very poor because they produce at very low levels. And they produce at very low levels because they don't have money to invest in their production. And so the question is how you break that circle, no? Ideally, you would provide them with funding, with external funding. So ideally, you would provide them with loans so they can start investing more in their crops, adding some money for irrigation to try to increase their productivity. And once they increase their productivity, they will have more money to invest, and they will have a positive loop. But in general, the question probably goes deeper than that, because you were saying, well, we are doing something here that we probably shouldn't be doing, no? So the question is, well, where do we grow the food? We should grow it in areas where it's suitable for growing food. And that would work if we had an ideal world in which we would see the world as a whole unit, no? So we could say, well, this whole area is not good for growing food, so let's grow it somewhere else. Let's grow it where it's suitable. But in those areas, people are probably doing something else. So we would have to really have a better management of the world to say so, no? And that, unfortunately, doesn't happen because every country tries to work individually. We don't really, in terms of food production, we don't really work very well as a unit, no? And so that's very evident when we see problems with food security, no? Many countries on the same year are producing too much food, and at the same time around the world, some countries are starving because they don't have enough food. So if we had a better distribution system, then that would be avoided. But again, unfortunately, our system is not that well oiled, no? And so food production is something that is really, there's a lot of room for improvement, no? Distribution has to be better. Waste has to be reduced, no? Statistics show that about 1/3 of the food that we produce goes to waste. 1/3 of the food. And so with that food that we send to waste, we could feed everybody who's starving in the world, no? And so it's really a problem of how the system is not working correctly. But changing the world system is not that simple, and we see it, no, in many different problems.
I'm afraid you're going to have to conclude, we can chat maybe as you finish up the food so we have no waste. Dr. Cassiano.
Thank you.